Hello guys, welcome to Cisco with Aman Soni, and this is the fourth lecture of the Cisco switching series. In this lecture, we are going to continue where we left off in the last part. The last part where we left, we have done the step number 1, how to select the root bridge. So we already know after connecting the links, we have what? We will be having the STP election. Let me remove these things, we don't need these. Okay, we just connected the three switches, and the very first step is select the king. Who is going to be the king of the network? And who is going to be the king, also known as the root bridge, is the bridge that is having the least bridge ID, the lowest bridge ID. What is bridge ID? The combination of the priority and the MAC address. The default priority is 32768, and the VLAN ID is being added to it, that is known as extended system ID. So if my VLAN is 1, then my extended system ID is 1 as well. So that is why 32768 plus VLAN 1, 32769, and the remaining part is my base MAC address. Every switch is going to have its own bridge ID. After connecting, as we have seen in the last video, you to go to any switch, and if you do the command show spanning tree, let me just do that thing for again, show spanning tree. It is saying the information of the king right here, and this is the information of myself, meaning the current bridge, the current switch. So he's saying my priority is 32769, my base MAC address is this. Who is the king? He is having the priority 32769, and his identity is actually this whole thing. This is his bridge ID, or you can also say the root ID. What is root ID? Root ID is nothing special but the bridge ID of the root bridge of the king. So the root ID is this. So who is your king? The guy having the MAC address, this thing, and at the end 100. As you can easily see, this is the king of our topology. So step number 1 is done. So let me show you just all the steps I have here in the notepad. Elect the root bridge. We are done. Second thing, you have to go to each switch. Actually, I should say each non-root bridge. Actually, these terms are quite confusing. So you can just remember that step number 1, elect the king. Then go to the remaining switch and elect the RP. RP is the root port. What do you mean by root port? Root port will give you the best path to reach to the root bridge. It will provide you the best path to reach to the root bridge. That is the job of the root port. And every other switch, all the remaining switch apart from the root bridge, is going to have only one special port on them, that is known as the root port. And in step number 2, we are going to do election. After the election, you will know who is the root port on each and every remaining switch. It doesn't matter if you are going to perform this step on switch 2, on switch 3, you can just choose any other switch one by one. If you are taking switch 2, go on switch 2, elect the root bridge, then go to switch 3, elect the root bridge, and same thing if you have other remaining switch also in your topology. So let's continue. So the question here is, what is the election criteria? The election criteria is pretty straightforward if you follow the video with me. Otherwise, spanning tree can be very complex. Just remember each and every term clearly in your head. What is root bridge? What is step number 1? What is step number 2? What is root port? Why do you need root port? So that you can have a best path to reach to the king. How to do elect the root port? This is the election criteria. The very first thing you will look, the port which provides you the best cost to reach to the king, or the I'll say the technical word, the root bridge. This is the step number 1, the port which will provide you the best cost to reach to the root bridge. So you can say, like, I really don't know what about cost much. You might have studied cost in OSPF, and believe me, it is not that cost. In spanning tree, depend on your what type of link you have, you will be having some cost. I have a table for you right here. Let me show it to you. This is the cost parameter for our spanning tree protocol. If you are having 100 Mbps link, then your cost is 19. If you're having 1 gig or 1000 Mbps, cost is 4. For 10,000 Mbps or 10 gig link, cost is 2. And in our topology, we are having 10 Mbps link, so our cost on each and every link is going to be 100. So let me just put it right there in my topology. What is the cost of this link? It is 100. What is the cost of another link? It is 100 as well. What about the other port? The cost of this link is 100 as well. Okay, so cost is right there. Why do we need cost? Because it is the very first parameter in our election criteria. The cost. The port which will give you the best cost to reach to the root bridge will become the root port, because we are doing step number 2 right now. What if in some cases the costs tie? Imagine you have two ports and from both ports the cost is coming, let's say 400. So port E01 giving you 400 cost, port E02 both also giving you 400 cost. Then what? Then you will move to the step number 2 of the election criteria. But always remember, only if the criteria number 1 ties, then only you will move to criteria number 2. What is the criteria number 2? The criteria number 2 is the lowest bridge, or I should say lowest sender bridge ID. The switch or bridge from which the packets are coming, the switch which is giving you the lowest bridge ID will become the root port. Okay, so just go through them. No need to imagine in your head, because for this we are going to do a lot of topologies in which I will show you all these characteristics come into play one by one. What if, just remember, step number 1, select the port with the best cost. What is the best cost? Obviously, it is quite simple. The one giving you the least cost is the best one. Second thing, if it ties lowest sender bridge ID. What if in some case, if you remember correctly in my previous lecture, I talked about you might have a case where your bridge ID might be tying. If bridge ID also ties on both ports, then you are going to do the third thing, the lowest sender port priority. Yes, there is one more priority apart from the bridge priority, which is in the bridge ID. It is different. Let me clear it for you. Every bridge have a bridge priority. This is that. But every port also, my friends, have a port priority, and by default, I can write also here, the default port priority of every port is 128. Okay, what is the final step? What if the sender port priority also ties? And usually in all the cases it will be tying by default because it is 128 everywhere. If this priority also ties, then you are going to look at the lowest sender port ID. Which sender port ID? This port ID, my friends. These are their port IDs. Okay, so they will never tie because all of them on a switch is going to be unique. Okay, so just read them, go through them. No need to imagine or implement them, because for that I'm here for you. I'll be showing you one by one. And more than that, we're going to use this election criteria right on switch number 2. So where were we? Step number 1 done. Select the root bridge. We are on step number 2. Go to remaining switch and elect what is known as the root port. For that, this is the election criteria. So let's go to switch number 2. Okay, what is the cost from this port? You need to see the ports, right? So I'll click here and show you the ports. These are the port numbers. E00 here, 01, 01, and this here. Okay, so what the cost from E00? You can clearly see the cost is 100 from this side. Okay, let me take you to the snipping tool so that I can show you more clearly. The cost from this side is 100. What is the cost on this port? Look clearly, the cost from this port is actually 200, my friends. It is 200. The cost from here is 100 only. So the very first step of the election, the port which will give me the best cost is going to be the root port, as simple as that. So in this case, this guy wins the election and he is going to be our root port. Okay, so this is the root port according to our hypothesis, according to our election. What is the state of this port? We don't know, because that we are, see, if you want to be good in spanning tree, follow the process step by step. If you're going to think, okay, what is the port, is it blocking, or is it RP, or is it DP, or what, you're going to be confused. Moreover, see, this port will either be only a DP or a block, because there are 3 port roles only: RP, DP, and block. So on every switch you will be having only one RP. Also, if this guy is RP, then there is no way the other port is going to be a RP. This port is going to be a DP or a block. What is the role? We don't care right now. So we are going to do the same thing for the other switch also, but first I'll write here, according to our hypothesis, this is going to be RP. Okay, what about switch 3? Let's do the same thing here as well. And just to be clear with the real life scenario, whatever we are doing right now, spanning tree has already done that. Okay, it's our job to understand how the algorithm really works. If I go on the switches and if I show the do the command show spanning tree, it will show me which port is root port, which is DP, which is block, everything. But we want to do it step by step manually. So we are right now on this guy right here. This port, what is the cost? The cost from this port is 100. What is the cost from this side? To reach to the king, obviously the cost to reach to the king is 200. So same thing, this guy also win the election here, and he is the root port right now. So what we'll do, according to our election, this guy is root port here. Okay, let's move on to the steps of the election. Oh, right here. Elect the root bridge, go to each non-root bridge remaining switches and elect the root port. It is done. We, apart from the king, we have only two switches. On this E00 is the root port and this E01 is the root port as well. Okay, what then? In front of the RP, there always is going to be a designated port. What is a designated port? Let me show you. A designated port is a, for simple C, it is just a normal forwarding port. You can send receive data, and each port on a root bridge is a DP. And also let me add one more fact here, that whenever you are having to have a RP in front of a root port, there is always going to be, there is always a RP in front of, oh sorry, my bad, DP. In front of a root port, there is always going to be a designated port which is in forwarding state. Okay, so that's why we have our step number this. In front of each RP, there is a designated port which is forwarding. Both are forwarding, RP and DP, but RP is a special role to perform to give you to the best path to reach to the king. DP is just your normal forwarding port, that's it. So in front of, if this guy is a RP, then this guy have to have a DP. More than that, elect the root bridge. When you select the root bridge, there is a rule, very simple rule for that. I'll mention it here as well. Every port on the root bridge or the king is going to be DP. It is also there. So this is just like cross checking. So step number one, elect the root bridge, and it's a rule that every port of a root bridge is going to be a designated port. Done. Step number two, go to each switch and elect the root port. Okay, switch number two, this is the root port. Switch number 3, this is the root port. And step 3, you will just cross check. If there is not a DP in front of RP, then you will make one. So in front of this RP, there is a DP, check. In front of this RP, there is a DP, check. If it is not there in bigger topologies that we will see in the upcoming videos, you will make that guy DP. In front of RP, you can never have a blocking port because RP will give you the best path to reach to the king. Okay, let's go to the step number 4, the last step. Go to the rest of the links, remaining links. What do you mean by rest of the links? After this, some links will be there on which no election happened. So on this link, no election happened, never whatsoever. There is no DP, no RP, nothing. We haven't touched this link ever. So on this link, one port is going to be a DP and one port is going to be a blocking port. So how you will do that? The answer is the same election criteria. This is the good thing about spanning tree. You just have to remember all these 4 steps for the election. For the root port, same thing. For the DP and blocking election on the remaining port, same thing. So whichever port will win the election will become the DP, and which will lose the election will go into the blocking state. So let's go here. Same thing, step number 1. The port which provide you the best cost to reach to the root bridge. Okay, so we are doing the election on this particular link. So let us take it to our snipping tool under our magnifying glass to further analyze. So either this port Where is my cursor? Right here. Either this guy or this guy is going to be DP, whoever wins the election. So see, be careful, this port actually lies on this switch and this port lies on this switch. So what is the first thing? What is the cost, right? Okay, what is the cost? The port which provide you the best cost to reach to the king, to the root bridge. And from this port, tell me what is the cost. You might say the cost is 100 from here and 200 from here. Never ever do this super silly mistake, my friends, because it is already mentioned the best cost, which will provide you the, you don't even look at the 200 cost, right? Because it is much more. You will simply say, if I am sitting on this port, obviously which is on this switch, and from this switch, the best cost to reach to the king is 100. So perfect. The cost from this port is 100 because it is on this switch. You will never even take this path. Why? Because you always first thing choose the best cost, and moreover you will be going from RP only. RP is like a gate or a like highway which will provide you to the best speed, best distance toward your king. Okay, okay, so this is the cost 100 from this port. What about our other candidate? What is the cost from this link? The cost from this port which is on this switch is also 100. Again, same thing, we will always select the cost to reach to the king from RP. You will never ever say, okay, from this port the cost is 100 from here and 200. No, 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 never. You will not even consider that. Okay, so both ports are providing me the cost of 100 from this side and 100 from this side as well. So good thing, now I can show you the step number 2, the port which provide you the best cost to reach to the king. In our case, in our scenario, we cannot decide because the cost from both ports are same. Both are giving me 100. What is the second thing? Lowest sender bridge ID. In simple thing, when they exchange BPDU, after exchanging the BPDU, which port is having the lowest sender bridge ID of the switch, obviously, because ports don't have bridge ID, switch does. So what is the bridge ID of this guy? It is written right here in front of you, and this is the bridge ID of this guy. So in short, this step says whichever is having the lowest bridge ID will win. So when you compare 32769 A B B like this, 3276, oh my bad, it should be 9 here also. I never change it. It should be 32769 because all of them are having the same priority. So let me just recopy it again from the topology. Silly mistakes. Three, because see, the priority is same for everyone. 32769, 32769 and 32769. Okay, so the cost from here is 100. The cost from here is 100. From this port is 100 as well. But this guy will win when it comes to the bridge ID because he's having the lowest, because in the end it has a 200 and this guy has a 300 right here. So now what will happen? The election is complete. This guy won. So this guy is our DP. He is the winner of the election. He is the designated port. And this guy is the blocking port because it loses the election. And now with this your whole STP is over because you have all the roles selected on each and every single port. These two guys, DP, this is RP, this guy lost the election, he is the in the blocking state, or you can say blocking or alternative, and this guy won the election, he is the designated port. How you will check whether your whole steps were right or wrong? You will go to the switch and do the show spanning tree. For example, E00 and E01 are DP on this. So let's go to switch 1 and we will do show spanning tree. As you can see, E00 and E01 are into, the role is designated and the state is obviously forwarding because both designated and RP are into the forwarding states. More than that, this is the king, this is the root bridge, and all the ports are into the designated state as I showed you in the rule number 1. Let's go to switch 2. It says E00 is root port and E01 is blocking. Okay, it should be what's saying on switch 2. Show spanning tree. I'll do it again. E00. As you can see, my E00 is the root port, and as you can see on all the ports, E00 is only the root port, because on every switch, on every non-root bridge, there is only one root port. And what is this E01? As you can clearly see that E01 is your alternative or blocking port. So the thing is done. And let's go to the switch 3. Switch 3, E01 is RP, so let's quickly go there and confirm it with show spanning tree command. Okay, it is here. E01 is the root port, only this. On every switch, on every known root bridge, only one root port, because the election says so. E01 is the root port. And what about E00? The E00 is the designated port. Okay, we don't care about the other ports. Most probably if they are on, they will be in the designated state, but we only care about the ports that are working, having working links in our topology right now. So this was your very first example of implementing spanning tree protocol algorithm. In my next video, I am going to take a little more complex topology, and we are going to perform all these steps together. These are the steps of spanning tree algorithm. I'll do one thing. I'll paste this whole thing onto the link description, on the video description, the STP algorithm and the election steps. So thank you guys, thank you for watching the video. Please follow all the lectures sequentially, else you might get confused, because this is the lecture number 4, and in the upcoming lecture, if you don't know this whole algorithm steps, you are going to be confused like hell. So in the next video lecture, I am going to take a little more complex topology and perform the same algorithm on that. So keep tuned and stay up and keep up doing the spanning tree protocol. Like the video, I will appreciate your feedbacks, and if you haven't subscribed to the channel, click on that subscribe button. Thank you. Aman Soni signing out.